Introduction to Trigonometry. Introduction. Introduction. Trigonometric ratios. Finding value of trigonometric ratio. Dear students, let us study a new topic related to right triangle, trigonometry. In this lesson, we will study introduction of trigonometry. Introduction. If a boy is looking towards a top of Minar and assuming that the ground making right angle with Minar, can you imagine by using trigonometry, we can calculate the exact distance of a boy from top of a Minar? Trigonometry is the study of relationships between the sides and angles of a triangle. In this chapter, students, we will study some ratios of the sides of a right triangle with respect to its acute angles called trigonometric ratios of angles. We will restrict our discussion to acute angles only. Trigonometric ratios. Let us take a right triangle ABC as shown. Here, angle CAB is an acute angle. Note the position of the side BC with respect to angle A. It is opposite to angle A. We call side BC as side opposite to angle A. AC is the hypotenuse of the right triangle and the side AB is a part of angle A. So we call side AB as the side adjacent to angle A. Now if we consider acute angle ACB, side AB becomes side opposite to angle C and side BC becomes side adjacent to angle C. AC remains hypotenuse. Observe the following ratios of sides of a right triangle with respect to acute angle A. We call them trigonometric ratios. The ratio of side opposite to angle A to hypotenuse of right triangle ABC is called sine of angle A. We have side opposite to angle A is BC and hypotenuse is AC. Therefore, sine of angle A is equal to BC upon AC. We can read and write sine of angle A as sine A. If we invert the ratio becomes cosecant of angle A. Therefore, cosecant of angle A is equal to AC upon BC. We can read and write cosecant of angle A as cosec A. So, the relation formed between sine and cosec as cosec A is equal to 1 upon sine A. The ratio of side adjacent to angle A to hypotenuse of right triangle ABC is called cosine of angle A. We have side adjacent to angle A is AB and hypotenuse is AC. Therefore, cosine of angle A is equal to AB upon AC. We can read and write cosine of angle A as cos A. And if we invert the ratio becomes secant of angle A. Therefore, secant of angle A is equal to AC upon AB. We can read and write secant of angle A as sec A. So, the relation formed between cos and sec as sec A is equal to 1 upon cos A. The ratio of side opposite to angle A to side adjacent to angle A of right triangle ABC is called tangent of angle A. We have side opposite to angle A is BC and side adjacent to angle A is AB. Therefore, tangent of angle A is equal to BC upon AB. We can read and write tangent of angle A as tan A. And if we invert the ratio becomes cotangent of angle A. Therefore, cotangent of angle A is equal to AB upon BC. We can read and write cotangent of angle A as cot A. So, the relation formed between tan and cot as cot A is equal to 1 upon tan A. From above, we can determine the relation between sin A, cos A and tan A. The relation is sin A upon cos A is equal to tan A. Do trigonometric ratios vary with lengths of sides of right triangle? Let us check. For right triangle ABC, sin A is equal to BC upon AC. Suppose P is any point on hypotenuse and PM drawn perpendicular on AB. We get a new right triangle AMP. Therefore, in right triangle AMP, sin A is equal to PM upon AP. Now suppose hypotenuse AC extended up to Q and drawn a perpendicular on AB. We get a new right triangle ANQ. Therefore, in right triangle ANQ, sin A is equal to QN upon AQ. For the same measure of angle A, we get 3 ratios of sin A. As left hand side is same, the ratios in the right side are also same. Therefore, sin A is equal to BC upon AC is equal to PM upon AP is equal to QN upon AQ. Similarly, ratios for cos A and ratios for tan A are also same. Therefore, we can conclude that the values of the trigonometric ratios of an angle do not vary with the lengths of the sides of the triangle if the angle remains the same. Can we find the values of other trigonometric ratios if value of any one ratio is given? Let us check. Consider ABC is a right triangle and tan A is equal to 4 by 3. We know that tan A means ratio of side opposite to angle A to side adjacent to angle A. Therefore, tan A is equal to BC upon AB is equal to 4 by 3. It means if value of BC is 4 times of K, value of EB is 3 times of K, where K is any positive number. Now to find other ratios, that is, value of sin A and cos A, we need to find value of hypotenuse AC. Let us use Pythagoras theorem to get value of AC. Therefore, AC square is equal to AB square plus BC square. AC square is equal to into bracket 4K whole square plus into another bracket 3K whole square. We get AC square is equal to 25K square, hence AC is equal to 5K. Now, sin A is equal to side opposite to angle A by hypotenuse. Opposite side to angle A is BC and hypotenuse is AC. BC is 4K and AC is 5K. Therefore, sin A is equal to 4K upon 5K. That is, sin A is equal to 4 upon 5. Similarly, we can find value of cos A and we get cos A is equal to 3 by 5. So we can find the values of other trigonometric ratios if value of any one ratio is given. In this subtopic, we have learnt 1. In a right triangle ABC, right angled at B, sin A is equal to side opposite to angle A upon hypotenuse. Cos A is equal to side adjacent to angle A upon hypotenuse. Tan A is equal to side opposite to angle A upon side adjacent to angle A. 2. Cosec A is equal to 1 upon sin A. Sec A is equal to 1 upon cos A. Tan A is equal to 1 upon cot A. Tan A is equal to sin A upon cos A. 3. If one of the trigonometric ratios of an acute angle is known, the remaining trigonometric ratios of the angle can be easily determined. So that is all in this subtopic, students. We will learn trigonometric ratios of some specific angles in our next topic. Till then, keep learning.